Continue our exploration of imaginary and complex numbers by talking about how we add and subtract them. Reality is it's very similar to when we had algebraic expressions with variables. So let me grab a pen here and we'll go through a couple of these together. So essentially what I'm looking to do is to combine my like terms by distributing anything I need to and then looking for my like terms to put together. So for instance, like 2a, I could take 3 and I could distribute it to the x and the negative 4, giving me 3x minus 12. And the same thing to the 2, giving me 4x plus 10. So my goal then is to be able to put those terms together. So my like terms are 3x and 4x, which would give me 7. I wrote 4, I don't know why, 7x, and negative 12 and 10 would give me negative 2. And so together, those are my like terms. I could do the same thing on number 5 with a negative 4. I can distribute to those two things. This is where it gets going to get a little bit tricky, is distributing a negative. We often lose that negative and distribute just the number part of it. So the negative 4 times negative 2 is 8x. The negative 4 times negative 5 is 20. And I'm going to take 3 and distribute the same way. So 9x plus 21. Again, combine my like terms. 17x plus 41. So that's all great and wonderful, and that's really a review of things you've done before this lesson. But when we're looking at an expression with an imaginary number, it's actually not any different. If we have a number out in front of parentheses, we're still going to do any distribution. If we have like terms, we're still going to put them together. So on a question like 3b, we're going to take our negative 9, distribute it to both terms that are in the parentheses. That gives us 13 minus 9i plus 36 plus 2i. Then we're going to put our like terms together. Again, we want it in the form a plus bi, so we're looking for the real number component first. So my real numbers in this case are 13 and 36, which would give me 39, and my imaginary numbers, negative 9 plus 2, would be negative 7i. So a lot of familiarity is what we did previously when we did this with variables. So a question like 4b, all my terms are all listed out ready to go. I'm just looking to put like terms together. So I've got negative 37 and negative 8 is negative 45. And for the i's, I've got negative 2, negative 4, and negative 5. So that's negative 11i. So hopefully so far it's pretty straightforward. We're going to step it up just a little bit on this next set of problems. So in this set of problems, our directions are going to be very similar. We want to rewrite in the form a plus bi. We're going to add an additional step, classify our answer as real, imaginary, or complex. Just take a quick second and preview those questions and how they're a little different. The biggest thing I'm noticing is that now, instead of just having things in terms of I, we have I to the third, I to the fourth, I to the sixth, and so on. So let's grab a couple of these and we'll go through them together. It's like 13. We have 3i to the third plus 4i squared plus 7i minus 3i to the fourth plus 8i to the sixth. Just based on the exponents alone, I think it's likely that I'm still going to have imaginary numbers left over because I'm seeing two exponents that have odds. I'm seeing some evens as well, so I know eventually some things are going to cancel and turn into real numbers, but we're not quite there yet. So my first step is to look at something like 13, where we have 3i to the third. I to the third, again, we already talked about being negative I. I squared, we've talked about being negative 1. I to the fourth, we know is 1. And I to the sixth, if we step back a little bit, we know that's the same thing as I to the second, which is negative 1. So this gives me negative 3i minus 4 plus 7i minus 3 minus 8. So I'm looking to put my like terms together. I've got a negative 4 and a negative 3 is negative 7. Take away 8 more, that's negative 15. I've got negative 3i and 7i, that's 4i. I've combined my like terms. I've rewritten in the expression in the form a plus bi. My next step is just to classify, and again, I'm seeing a real number component and an imaginary component, so I'm going to call that complex. So what about a question like number 15? On number 15, we have a lot of different pieces here. We've got a negative 15, 5i to the fourth, negative 7, 8i squared, and 9i to the 12th. Challenge on this one is that our exponents are relatively large. So I'm not going to do anything with that negative 15 yet. And if I need to, I don't know. I to the fourth, I know that'll become 1. I to the eighth, and I'm kind of stepping back a little bit. I to the eighth, taking away 4, that's the same thing as I to the fourth, which is 1. And then 9i to the 12th. I to the 12th is this also the same thing as I to the fourth, so that would become a 1 as well. So I'm now left with negative 15 plus 5 minus 7 plus 9. So I'm just going to look to put those together. It looks like I have no imaginary numbers left, which I might have been able to quickly identify because of all those even exponents. So negative 15 and 5 is negative 10. Take away 7, that's negative 17. Add 9, I get negative 8. And oops, which is a real number. All right, let's do 16 and then we'll kind of call it a video because it's kind of the same thing over and over again. First thing I want to do is I want to distribute that 3. So that gives me 12i minus 24. And I know that's going to be I squared, so I'm going to go ahead and change that right now to be a negative 1. I'm going to distribute the negative 4. So that'll become negative 32i squared, which again, I know I squared would be negative 1. And negative 4 times 17 is negative 68i. And negative 4 times 11 is negative 44. So again, like terms, I know this will become a positive 24, and this will become a positive 32, so that's 56. Take away 44 gives me 12. And for my imaginary components, 12i minus 68i is negative 56i. So I've got a real number component and an imaginary component, so that would be considered a complex number. So again, our goal with addition and subtraction is fairly basic. We're looking to distribute exponents where we need to, combine like terms where we can, and then to classify our final result.